Hello again, everyone. Lovely to see you. I hope you've had an interesting afternoon so far. It's about to get all the more interesting because now it is time for our expert panel on the topic embedded AI. We've been looking forward to this all day, and I look forward to handing it over to Axel. Now, I can only say on behalf of a consumer that we use embedded AI and AI-based applications all day long. Most of us are not necessarily aware of that fact as a consumer, once more, but I really look forward to finding out which current developments are going on in the industry, and I look forward to the exciting news. So Axel, please take it away as the moderator of this panel.
Okay, thank you, Yasmin. Yes, and indeed, we, in this 19th years of embedded world, we chose a motto, as you know, embedded intelligent systems. So for us, it's intelligence is one of the cornerstones for the development of the ecosystem. You might remember that the predecessor of embedded world was called embedded intelligence back in the 90s. At that time, it was rather a dream or a vision for the future. And the question is, are we already there, or where are we in the development towards intelligent systems? We already have a lot of intelligent systems, as Yasmin said. We see them mostly around smartphones, but also around autonomous driving, image-based processing, and there are huge opportunities, obviously, that are available. We believe that on the other side, intelligence as such is not the target alone, but we are talking about systems, so distributed learning, sensor-based learning, collecting data at the edge, learning in the cloud, deciding in the edge, or something in between might be also an alternative. So lots of different facets of embedded AI, and I'm very happy to talk about these and other questions with three panelists, and I'm very happy to have three excellent panelists with me to discuss these issues. I go through the names in alphabetical order. Luckily, it's the same for Christian name and family name. So let me start with Andrés Mlinar first, who is a senior software engineer at Asia Arthos with Microsoft in Munich, where he develops IoT embedded software with the Asia Arthos team. Andres has extensive experience in embedded software, Arthos safety critical systems, embedded test and measurement tools. As a field engineer, he helped teams deliver successful projects in the automotive, aerospace, industrial, medical, and consumer industries. Before joining Microsoft, he worked on safety-critical operating systems at Green Hills, and before that, he was with Express Logic and iSystem. Let me also mention that Andres, with his team, won the Embedded Award in 2018, that means 3 years ago, for an embedded AI engine. And originally, Andres comes from Slovakia and completed his computer science engineering degree from the University of Ljubljana. Andres, very warm welcome to you.
Here.
The second panelist is Eddie Seymour, who is European Director for the Embedded Business of Nvidia in Oxford, UK. He was one of the first members of Nvidia's embedded and automotive team, working with European car manufacturers on the first GPU-based infotainment systems. With the introduction of Nvidia Jetson embedded platform, Eddie now manages the growth of new embedded markets in industrial robotics, autonomous machines, UAVs, and artificial intelligent systems. And then the third panelist, we also have Jan Werth, who is lead data scientist at FITEC, Messtechnik in Mainz, Germany, which is also his hometown. After being a professional cabinet maker, Jan entered his studies for electrical engineering with the University of Applied Sciences in Trier and finished his master in Eindhoven with Philips Research. Currently, he works for FITEC Messtechnik in Mainz as lead data scientist, where he is responsible for all data-driven solutions. Jan Werth has over 10 years of experience in signal processing with a focus on machine and deep learning. And what I find interesting about all three panelists is that they are excellent, that's one, that's clear, but they come from different backgrounds, and therefore I believe that also the viewpoints of our today's discussion will be very diverse. So, very warm welcome to you, and happy that you share the time with us. Let me start maybe with one warm-up question. how would you describe the state of the art? Where are we in the introduction of embedded AI into the real world? Maybe if you like, let's just follow the alphabetical order and start with Andres first, and then afterwards we'll change. Don't worry.
Yeah, thank you. I see two paths that the current development is taking. The very small devices in which you see silicon vendors incorporating some sort of acceleration into their chips, and then the very high end with Nvidia under Jetson and more specific for AI development. And of course, as every new industry, you will see gradually people filling up the middle. And I think this is currently what we are seeing. So this year, we probably see in the embedded world a lot of silicon vendors announcing new silicon with AI capabilities.
I see nodding heads. So do you agree, Eddie?
Yeah, I think Andrés there. So, I mean, I would say, I think everybody thinks that this is sort of, an immediate effect. That's sort of not the case. I mean, if you look at it in the early 2000s, we had the Big Bang, which we saw that there was a way that we could transition from traditional computing power, such as CPUs and FPGAs. Of course, from our point of view, GPUs allowed us then to bring in the advent of accelerated computing. This certainly for, I would call it, the sorts of universities and higher education gave them a platform in order to really think about AI and how they might do it. And I mean, AI, as you know, has been around for many years as a terminology, but perhaps we never had the acceleration at that time to really be able to bring really cool applications into this world, okay? I mean, we're now seeing many projects, and it's a bit, I like to use the analogy of a mobile phone, as you did, Axel. In the early days, you have to put the infrastructure in place, and today we're putting that infrastructure in place, whether that be in training or simulation. But ultimately, as consumers, we love devices, right? The mobile phones of the world, and so we're going to see those saving devices, it could be vacuum cleaners, it could be cutting the grass, and we're going to see a whole range of new business models. And I think that's what we're really at now, is both from a technology and companies looking to adopt and deliver that. And most of those are new startup type companies. And we're in a new industrial revolution, the fourth industrial revolution, we like to call it. And if you look at steam and electric, and I like to pick on electric, look how long electric's been here, and yet we've just got into the world of electric cars, right? So these things are many years that take that adaptation. So, the answer is it's here, and we're going to see some really cool devices as people really figure out how to use it, and some really cool business models.
Great. Jan, would you like to add something?
Yeah, sure. There was actually really great points for the speaker before me, and maybe what I just wanted to add is that it started quite early already, right? So with the Jetson, maybe Andrés can, Eddie, you correct me if that's wrong, but I think in 2014 you had the first Jetson out, so it's relatively old. And then going on, and actually for data centers, we have seen for a long time now really very well-designed, dedicated AI chips. And just was, let's say, with the beginning of 2019, the first chips came out, like with Google Coral board, for example, the first dev board, development board for like a desktop solution, and just to trying out, or like for us, just to try something out and not having a data center. And if you look at the scene now, because that was in like early 2019, was like one of the first chips coming out, with others in production. But if you look now at the scene, it's over 100 vendors which offering different chips, like startup companies, but also like really old, like big companies in the field. So I would say just a couple of years, it was a really fast liftoff, to be honest, right? And even AI in general, like the mainstream AI, since when is it on? Like the Keras and TensorFlow was developed in like 2015 or rolled out in 2015, so it's all that relatively new to be compared to electric, as definitely relatively new. And you have seen what we have seen in changes already since 2015 up to now is just amazing. Yeah.
maybe, Eddie, you mentioned that people love gadgets and devices. Um, we now have here two companies which are traditionally hardware vendors. And how do you feel about this? I mean, maybe Jan, you would like to comment first, because I was pretty much surprised when I saw you working for Fitech, which for me for a long time was really traditional hardware vendor. How do you feel there? Are you the bird in the aquarium, or how do you view on this?
Yeah, to be honest, that's an interesting question. To be honest, I have to give a big shout out to our CTO, Bodo Huber, because before it was really in all the press and you could read it everywhere, like embedded in AI. He already thought that that should be a good combination. And kind of we found each other because I kind of thought the same thing and thought, okay, there are a lot of companies out there who can do AI software, especially nowadays. You find just, if you need somebody, just post it to the internet, you will find a solution with somebody. But having somebody experienced in embedded and then combining that with AI, at least in the beginning of 2019, 18, was relatively new. And yes, of course, when I entered the company, you can imagine like an electronic company, there were some, let's say, hesitance. I was like, okay, you guys, okay, now we also have AI. Apparently everybody has to have it, kind of like the buzzword feeling. But to be honest, nowadays it's really nice. So colleagues come to me and they're really interested in the topic. They know like AI is here to stay. It's not just something quick and going away again. So they come to me, they ask for insights, and sometimes they even join me when I give workshops. They're like, can I sit in just to gain knowledge on the topic, which I really like. So it's more like open and welcome instead of like, okay, what is that? Nothing new buzzword again. So please keep away. That was really really interesting. But yeah, nice integration.
Okay, Eddie, how is that for you? I mean, if you develop new architectures, bring out new devices, how do you collaborate with the software guys in order to have a neat hardware software co-design and functional split and so on? How can you give us a little bit of insight into how you're approaching this thing?
No, I mean, I think sometimes you know, the guys have mentioned Jetson, which, you know, some people think it's something that's out there, but for us, it's a platform, right? You know, in the end of the day, we are an enablement to companies to be, you know, collaborative design. I mean, I think that's the one big point from an AI point of view. You're not going to do this alone. It's going to be a collaboration of ecosystems, software partners, development, higher education, especially as they say that we're going into this new computing model. The new computing model being the traditional, I programmed it and it does a function. This AI is, you know, initially was a learning process, or, you know, a deep neural network learning process with information, just sensory information like humans have, and then deployment, which we call inference. And now we're actually bringing into this the whole world of simulation, especially if you look at the automotive world, that the ability to drive thousands, millions of miles is just not possible, you know. And so some people think that's quite weird, but actually as humans, we do the same. You know, you see my profile, I'm a private pilot, but in order to be able to train, we don't want to just jump into an airplane and off we go. We can do that within the world of simulation. So that builds into this whole ecosystem of being able to leverage many, many things. So again, from our point of view, our approach is a platform process which allows people to build products on the top that are unique to various vertical markets. And they are the knowledge base in my mind.
Mm-hmm. But how does it look from the business perspective? I mean, if we look into many of the software platforms that are available, they are open source, so it's maybe a little bit more difficult to earn money with that. How do you look on this split? Just giving the money to the hardware vendors, Andrés? I wanted to ask the software guy with us. Sorry, Eddie, if you allow. Andrés, how do you earn money with the software on the AI side?
Like Eddie said, it's a platform. I mean, the software is not just a package that you take and use, but it's a whole stack of things that have to come together. Mm-hmm. And well, next to the software, it's also a service necessary for that. what we see mostly in small devices is that people do the training on the cloud and the inference in the small device. And then that's where we, with Azure, enter into the game. And again, I mean, this is a big community. So in Azure, what you have mostly for training are Nvidia devices doing the heavy lifting.
Okay.
So it's a whole ecosystem of companies and institutions collaborating. Most of the cutting edge of research in AI, it's also produced by different universities and companies. And it comes out into the public almost immediately. I mean, I believe there are no big secrets in the background. So it's a collaborative effort.
We already mentioned a few applications like the autonomous driving. For the industry, what are your killing applications? What's the super use case that you would see, or maybe what are the use cases that you currently see? So you might answer in both directions. Eddie, sorry for interrupting you. Now you get the first one.
Okay. Yeah, no, I think this year's been an interesting one with COVID, especially, as you guys all know. And I think if you look at today with the world of vaccines, you know, a lot of our activity on deep learning and AI has been around the area of genomic sequencing, okay? Something that would have been impossible maybe even 18 months or 2 years ago, you know? And that's why we're able to get where we are with some of the vaccines that are out there. On the other side of that, you know, some of the companies we're working with, you know, and they won't mind me mentioning it because they're public about it, which is Nanopore. And you know, they built their whole applications on the back of the genome sequencing and in big data centers. But of course, a lot of these issues we need to be out in the field. So we're going to see, like the mobile phones, that a lot of that will transition from, you know, large data centers down to handheld and mobile devices that can be used in the environment where you don't have connectivity, where you don't have you know, the normal world that we perhaps live in. This could be in Africa or remote locations in Russia for oil refinery or oil transportation, where you know you need to be at that edge. So we're going to see the uses of those AI that was typically data center or on premise becoming handheld and mobile devices as well.
Yeah, I would like to add something to what Eddie just said. I believe the current revolution in artificial intelligence started in 2012, if I'm not mistaken, with a group that presented an image classification algorithm in the image classification Olympics of artificial intelligence. And they trained some image classifier for the particular data set that they were using in the competition with a couple of Nvidia GPUs. And well, it was a jump in that year from what was happening every year. You saw incremental, very small advances every year, but that year it was a jump. And after that year, the year after, there was another big jump. And by today, we consider that problem solved. It was something that 10 years ago, it was science fiction. And this year, a few weeks or months ago, we have seen the protein folding problem making the same step. And I just wonder what we are going to see next year or in the next couple of years.
Yeah, but please be prepared, Andrés. I will ask this question later to you, so please have an answer prepared. Jan.
Yeah. Maybe because now we're talking about like the peak of AI, and to be honest, it's interesting because I work for AI in a long time already in the field now, but I still have to constantly be updated and see, okay, what's new, what's happening left and right of me, and it's just amazing. But another part which is also really interesting is just more the broader perspective, because we have a lot of customers in the, let's say, like mid-sized companies from like not the tech giants, for example, who are anyways on the spear tip. But what I see now is that like also like mid-sized firms, and especially mechanical industries, because like I said, we talked before about where do certain fields stand, right? So electric engineers already out there for a long time, but even mechanical engineers is farther away from AI, to be honest, for the understanding, just for the natural working with AI. And I'm really impressed. I talked to a lot of management in mechanical industries, and they just grasp it. They see like, okay, we have to do something. And I see like overall of the whole landscape, at least in Germany and Europe, I see them picking up the pace. And of course, it's not like the super peaks and genome sequencing is more like, for me, it's, let's say, or people in the business, more like low-hanging fruits, but still, it's nice that they pick it up and they ask me like, hey, Jan, we have a problem. Could we solve that with an AI? I said, of course, this is obvious, but just that they ask a question and see there might be a solution in AI, this is perfect. So I think in the coming years, we will see a much denser grid of companies just using AI for base solutions, and not just for the peak thing, but just overall coverage of AI solutions. Might be really interesting.
Great. Before we go into the next question, let me please remind the audience that we have the Slido open. First questions are dropping in, and I'll try to integrate them into the flow. But please be more active on this Slido feedback channel so that we can also answer your questions. My next question, nevertheless, would go into the opposite direction. We now discussed, well, where it is attractive to use AI. In which case, would you not, or would you tell your customers or your colleagues, Jan, can we solve this with AI? And you would say, no, never, don't touch it.
So I'm also an engineer, so sometimes I say, do not invent the wheel new. So sometimes you have solutions. Let's say a simple counting algorithm, something is probably already out there, right? It's just edge detection or something like, not like, let's separate like classic algorithms and like deep learning, machine learning, etc. Right? So some things are a bit overshooting. But anyhow, of course, with like you can also solve these problems with machine learning. So to be honest, I would probably never say never, or rarely say never. But yes, of course, maybe focusing also on the embedded devices again. Of course, if you have a problem which happening in the internet, you wanna analyze consumers, for example, then I would of course say, don't go the embedded route. That's obvious, right? But for many other problems, I would say, anyways, go AI, go embedded AI. Why not, right? And so you reduce power consumption. You have less bottleneck in timing, sending data to front. You can reduce all of that with embedded AI. So I see a lot of benefits for that. So if you can use embedded AI, why not go this route?
Mm-hmm. Are there any issues with regard to safety and testing from your experience? Maybe also to the others.
Yeah, I mean, that's interesting. Yeah. So there's always a problem with safety. Just nowadays, we Google published, it's already a couple of months back, probably. It seems really new. Like the problem of under like the test, let's explain. Like they tested several models with the same data sets, and it was everything same parameters, etc., except for the input seeding points. And what happened is that the models in training were actually kind of all the same, had all the same performance. But then in the real world, with real life data, it didn't work out. So now a lot of people say like, oh my goodness, this is another huge problem with AI. And we saw something similar back then when we had adversarial hacks, right? So the first time adversarial hacks came up, people always said like, oh my goodness, AI will not work because there's a problem of adversarial hacks, right? The explanation that a small pattern which changes the prediction, even if it's obvious, like it's a table and you put a dog sticker on it, like a dog pattern, and suddenly it's a dog, right? And I remember that people said like, oh, AI is dead now because there's a problem. But I see it different. So it's a new problem, and that just strives to make it better. So the algorithms just become more solid and more sophisticated to overcome those problems. So I see a really bright future also for that. And even that with the latest problems coming up, I see, don't worry, people will be just recognizing, okay, we have to test better. We have to test with real life data and not just with our test data, which is probably from the same batch, right? So, and we have to frequently also test our models. If we implement it, we just can't leave it alone. We have to go back, check the models, check the performance. If something goes wrong, etc., maybe retrain the models. So I think it's just creates awareness that you just can't run AI free. Let run it free, but you always have to keep an eye on it. And I think it's becoming more and more obvious. And a couple of back in the days was just happy I can train it and it does what I want to do it. And now it's more like I know this, but now I have to check on it. Does it really do what I wanted?
Any additions from the others? Yes, please, Eddie.
Yeah, just to add to that, I think it's an interesting question you pose, Axel, is where you wouldn't use it. And my approach to that is same as sort of what Jan is saying, that you got to size the problem, right? You know, we engage many customers that say we want to apply an AI to this, but if they don't have the right people or the right data sets, or they don't realize what the size of collecting that sort of data model to do, maybe AI is not the best route for them to begin on this. They've got to be able to size that and understand that. And, you know, where we are today is primarily in a static world. You know, we can be, I'll call it the sexy toys like robotics and drones and all of those things. They're a dynamic world, and they're still developing. You talked about safety. In the static world, it's actually not so bad. And be aware, we work on the principle of what are we trying to achieve in terms of the quality or the percentage of accuracy. For what might be, you know, looking at food waste, the accuracy of 70% might be good enough, but it's certainly not good enough to drive an autonomous vehicle. Let me put it that way. So we have to sort of fix this for horses or courses, right? You know, I use the analogy, we didn't suddenly jump into the plane back in the early 1900s, right? The Wright brothers had to only do a first few feet, but it changed the world, right? From an airline travel. And that's sort of where we are moving in steps from an AI point of view. There will be particular projects, particular things that apply pretty well to this. And over time, we will get more and more, let's say, conversant with it to allow us to do more exciting things.
Great. Let me please ask you to give short questions. We are a little bit running out of time. There are lots of questions coming in, and we have only 13 minutes left. So let me try to get short answers from you. There are several questions going around the never-ending question about the hardware platforms. So one question about GPU versus FPGA. Which one is better? World is normally not black and white, and I expect that you will answer with the typical student answer. Well, it depends. So what does it depend on? Which one is better? When?
Maybe I can give a quick answer. I think it doesn't depend. I would always go GPU or NPU.
Okay.
Because the FPGA is really cost intensive. You have a specialist for FPGA programming. And then you need a specialist for AI and artificial intelligence. So you need at least 2 experts here. While if you go with a GPU, which, I mean, who doesn't know how to work with a GPU? At least if you're a data scientist, you definitely know how to run TensorFlow GPU, for example. On the other hand, if you need a bit more boost, let's say a bit more dedicated, you can go with the NPU. But mostly it's also very easy to transfer your models to an NPU unit. But the FPGA, good luck. I mean, yeah, I'm not an expert there, but I wouldn't touch it.
Eddie, let me ask you: do you have any good word for your competition?
I always have good words for our competition. You know, competition is always good, and other thought processes are always good. You know, and be aware we live in a heterogeneous system model, right? I mean, at the end of the day, as you've seen. We as a company have networking. We are working closely with ARM, you know, so we're very CPU dependent on that side of the house, plus GPUs. So again, I come back to the point was where do you apply it? Where do you load balance that? Where does the application best fit? You know, we have GPU is not just one graphics processor. It has multiple cores in there, you know, so the answer is, you know, we're an open platform, and that's always a good thing, right?
Mm-hmm. And there were also people backing one question, comparing the Nvidia GPU technology with ASICs like Intel, Myriad, Google Coral, or Halo. Could you give a short answer how you would see your USP in comparison with these other platforms?
You aren't asking me again?
Yes, because, well, it's obviously it's NVIDIA based oriented.
The most important thing, and I think Jan did a better job than I can probably do, which is, you know, I think most people are most familiar with GPUs. If you come from a gaming world, you're going to have a GPU in your laptop and PC. And FPGA is not something that it's a specialist, and it has its uses. But the GPU is most prevalent, right? So, you know, even from a Jetson point of view, you can buy a small Jetson kit for $50, a developer kit in a university. You can be a student. It's available to you, and you're going to be most familiar with that type of computing platform. So it doesn't matter if it's a GPU running on your laptop on x86 or an embedded system, and if you're using Linux, it's just there and out of the box. And I use the term a la carte menu because it's an open platform. Choose as little as you like.
Maybe small addition, just for the people in the audience. The big difference is here also, of course, power consumption. So it's very easy to start with a GPU. We have a lot of customers who start developing with a GPU, with a Jetson, quite often actually. But then if you go to, they want to do something on the edge, and then a dedicated NPU chip can be much lower in power consumption. So I think combination of both is interesting. Start off with where you know your steps, start on a GPU with Nvidia Jetson, for example, and then you come to a company like Phytech and say, you know what, I have the solution, but I know I need it to run on an embedded device. And then there might be different solutions actually, which are a bit more targeted for your embedded problem and solution then.
Yeah, and to give a small bonus on the side of FPGAs, depends really on the type of neural network that you're using. As you know, in neural networks, it's not so much about the processing, but more about the memory architecture. And there are some specific cases that are better tailored for the kind of distributed memory that you may achieve with an FPGA than with a GPU.
Yeah, thank you, Andrés. Could you maybe also give one or two examples of architectures that you would see there?
I cannot.
Okay, good. Fine.
I'm under NDA for those.
Yeah. Okay. There also was one issue that Jan, you already mentioned that one-time learning or training is normally not good enough, but you need to do continuous learning, adapting to changing environments and so on. In the real-world projects, and this was a question which comes up, how do you set up the systems? Still, there are lots of standalone systems without connectivity. How do you overcome this issue?
Yeah. So exactly, you have to recognize a lot of people think that when you call it a self-learning system, people think like, oh, wow, I just put a camera and it learns by itself. That's not the case, just to clear that out. So you train it, you test it, it's fine, you validate it again, and then you put it on your embedded device. So how to update that is while it's running, you mostly collect new data, you collect new insights. Depending, maybe you have also seasonal changes. If you are in retail, for example, people buy different things in winter than in summer, for example, you have to change your model according to that. So you gather data and you retrain and you see if you have improvement of your model, then you have to get it to your embedded device. And there are different ways. Of course, you can use, for example, Azure. There's an Azure IoT Edge device, a daemon, where you can train your model in Azure and then just deploy it via Azure IoT to your device. But of course, you could also do this with a RAW server, something in a private setting, or with your own server setup. So, but yeah, you have to have a connectivity at some point, or you have a model which is just solving your one problem and you actually don't want to touch it again. So then you maybe can actually have a remote device and not reiterate the training that actually can happen. There are problems which are just fine.
There's one other question mentioning the difference of edge learning or learning at the edge, learning at the cloud, distributed learning. How do you typically support your customers or recommend which way to use? Because especially I believe that distributed learning comes with the highest requirements of or highest dependency of systems, doesn't it? So which way do you normally go? What do you normally recommend?
Also for me?
No, maybe for the others. Okay. To be just.
For me, we're again, a platform that crosses all. I mean, the answer is training at the edge is probably today unlikely. We are a device or a sensor that's more in the collective or doing some functionality. Maybe Andreas is probably better suited for me than, whether it's on premise or in the cloud, that's sort of more of a business model or a setup. In our case, we tend to find the startups who who tend to have not cache rich. They don't want to put a lot of investment at the on-premise or locally. They will use a cloud type scenario. Others that are very sensitive. Remember, these data sets and these data, this data is the new oil, if you want to think about it. So they may view that as intellectual property that they don't want to go elsewhere. But, you know, from our platform point of view, you know, we're open to all of those models, and they're all available, whether it's a GPU in the cloud, on-premise, or at the edge.
Yeah, I agree with Eddie. Most of the training happens offline. I mean, having the edge device actually update itself in order to give different responses over time requires to know what the right responses are. So having some training there, it's difficult, but not impossible. Where it actually does work is when you have reinforcement learning. And these are some very clever applications today using that methodology, in which, yeah, some training in the edge will bring you to better results over time. But again, these are a minor part of what today's application, most of the cases are training offline and deploying for inference.
There are two problems actually with training on the edge. First of all, you cannot verify what is happening there. You can maybe, but that's another algorithm you have to imply to verify your training results. First of that, and second of all, the functionality of the training is at the moment, for example, for TensorFlow Lite, is not yet implemented. So I think it's on a roadmap, for example, that there's some training functions in TensorFlow Lite, but at the moment it's just a huge hurdle. So yes, training offline is recommended at the moment.
There was one question exactly also to TensorFlow. I don't know if you can comment on this. You just mentioned TensorFlow Lite is maybe not even working yet, but just in the process of being introduced. Do you see other alternatives than TensorFlow Lite for edge-based learning?
For edge-based learning, so for the experts, so generally, of course, TensorFlow Lite is around since quite a while, and it's if you use an NPU unit, like a neural processing unit, or however you want to call it, they have different names, but it's always the same. If you then use TensorFlow Lite, you most likely you have to use TensorFlow Lite, but the training is not available at that. Good question. If there, I don't want to say anything wrong, so I would say
okay.
I don't know if you PyTorch, could you train on the edge? I don't know, or MXNet. I'm not sure.
Okay. Yeah, I'm afraid we are running a little bit out of time. There are still lots of questions, but please be around afterwards. There's a possibility to also use the contact function on the Talk platform to contact the panelists directly and have more in-depth discussion. The question about getting the presentations afterwards, this is of course a clear yes. We will distribute this, and maybe I can also mention that the first videos are already available. So for viewing other sessions that you couldn't be listening to, or also revisiting such a panel, this also will be available within a few hours. Maybe as a last question with a request also for short answers. Andrés, you have to start. How will the embedded AI world look like in 2040? What will be different from now?
I really don't know. And I think it's impossible to tell, because if you look what happened 10 years ago or 20 years ago, it would be hard to imagine that you could predict what we have today. But I would agree with what the grandfather of deep learning, Hinton, said, that probably we are on the right path, that deep learning is a way to go. It's just that we are going to see a few more breakthroughs in this process. Developments like, for example, reinforcement learning, GANs, these have been amazing steps in the right direction, and we are going to see more of those. When we are going to get to a point that we're not going to recognize where we are in 20 years, it's hard to tell, but I believe that we're going to be surprised every year.
Okay, then let me make the question a little bit easier for Jan. So how will embedded AI look like in the year 2039?
Nice one. The problem is here generally, we humans tend to think linear, right? So what happened yesterday, what's happening tomorrow, but this development is definitely not linear. It's kind of some quadratic function, so it's really difficult to tell. But I think what's the next, at least the next steps, what's happening in the next steps is more general AI, so combining a lot of AI, what's already happening as you look at the robotics. But then also, I think, understanding context. So we now coming up with more looking into transformer networks, which is slightly combination of CNN and transformer networks, and then you're understanding context, understanding time, understanding location. Because at the moment, it's like, oh, there's a table, wonderful, but the AI is really difficult to put the table in a dining room, saying probably there's food on it, so it's completely detached from another. I think that we will see a lot, that there's more context in general, and then of course really stable baseline. I mean, now we have a lot of models already pre-trained on a lot of things, and I think this will grow drastically. And now people can use TensorFlow object detection API, for example. Very simple. You don't have to know anything about artificial intelligence. You already can use it. And I think this will grow. You will have plenty of models really well trained on a lot of problems of daily life. And then you just have to tweak them a bit to use them for your case. I think that will be the next future, at least.
Okay, great. Thanks. Eddie, last word.
Yeah, I'll keep it short.
But maybe for you, we can also make 2038 if you like, yeah?
Okay, a year earlier. I think from my point of view is that I'll go back, Axel, as I said, that this is a new industrial revolution. And I think, yes, there's always a fear when we have these inflection points. But as I talked about, steam, electric, the internet, they brought with them a great wealth of other jobs, other prosperity, solving problems for humanity. So these are big things, and that is what an inflection point like an industrial revolution does. So don't fear it, embrace it, and I think there will be really some great opportunities for every type of person in humanity to be able to adapt into that right now.
Great. Yeah, thank you very much. And thanks to all three of you for this nice panel discussion. Unfortunately, we are already at the end, still having a lot of questions at the Slido, which means that there's a huge interest and that we certainly will take up more space for this topic even in the 2022 edition. So thank you very much again for this interesting discussion, and looking forward to seeing you in live next year here in Nuremberg. Thank you.
Thank you.
Cheers.
Thank you.